Hello everyone, hope all of you guys are doing well, and this is your experiment 606, which is determining the empirical formula of magnesium oxide. Excuse me. So you guys can read the introduction, and also there is a sample calculation where you can go step by step and understand how the calculations need to be done. Also, here's the experimental details, and also you need to watch the virtual lab video so you will see how the experiment is being conducted in the lab. Excuse me. And then post lab questions, you don't have to worry about that. And then the data and observations are given in your data sheet, and I will show you how to do the calculation. That is what you need to turn in as your lab report. Okay, so the data sheet again posted on blackboard, and you will see mass of the crucible and cover in grams is given to you as 25.234 in grams, and this is there were two trials being done. So this is the data for the first trial, 25.234 grams, and then the mass of the crucible, cover and magnesium, 25.528. And then after the experiment is done, it's going to react with oxygen, so you're going to make magnesium oxide at the end. So the mass of that going to be 25.689 for the first trial. And for the second trial, these are the data: 439 and 23.615. Okay, so with this data, we're going to do our calculations. Calculate the mass of the magnesium reacted. So you have a crucible, and then you put magnesium in it, and then you have a cover. First you got the mass of the crucible and the cover itself, and then with the magnesium, and then with the magnesium oxide. Okay, so the mass of the magnesium would be then difference between these two, 25.528 minus 25.234. That will give you the mass of the magnesium reacted, 25.528 minus 25.234. And I will show you the calculations for the first trial, and you have to do the second trial. You will get the difference between these two for the second trial. So this one would be when you subtract 294 grams. Okay, also put the unit, and you can calculate this one here. Calculate the mass of the magnesium oxide formed. So the third data, 25.689 minus 25.234 will give you the mass of the magnesium oxide formed. Similarly, for the second trial, it would be 23.615. You subtract 23.152. That will give you the mass of the magnesium oxide. Okay, and I will give you the answer for the first trial, 0.455 grams. You can do this one. And then calculate the mass of oxygen that combined with magnesium. So this is the mass of magnesium oxide, and this is the mass of magnesium. So then the mass of oxygen you can find by doing this subtraction, 0.455 gram, which is magnesium oxide, subtract 0.294 gram, which is the mass of magnesium. That will give you 0.161 grams. So again, for the second trial, it would be the difference between these two you would do. Okay, once you get that, you have to calculate the average number of moles of magnesium that reacted. Calculate the mass. So you want to find out the average number of moles. So before you find the average number of moles, you need to find out the number of moles of magnesium for each trial. So for the trial 1, the amount of magnesium is 0.294. So you take that number 0.294 grams magnesium and you're going to convert it to moles by using the molar mass of magnesium, which is 24.31 grams per mole. That's the molar mass. You take the mass, you divide by the molar mass, give you the number of moles. And that would be 0.0121 moles. So grams to grams cancel. So you will have the number of moles from the first trial 1.0121. And you have to do the same thing for your second trial. So for the second trial, you take this number over here, okay, and then you have to calculate the molar mass. Not the molar mass, number of moles. I will do that calculation over here to show you, because I want to show you the next steps. And that number you take, okay, so not this number, I think it, not this number. You have to take the mass of magnesium. Okay, so the whatever the value you're going to get here, you take that number and you divide by the molar mass of magnesium. Okay, I'll do that calculation over here. 0.287 grams, you divide by the molar mass 24.31 grams per moles, and that will give you number of moles of magnesium for the second trial, 0.0120 moles. And then you need to write down the average number of moles. How do you calculate the average number of moles? You take your first trial 0.0121, add 0.0118 here, this number 0.0118. You add the two together and then you divide by 2. This will give you the average number of moles. That would be 0.010 moles. That's how you calculate the average number of moles, 0.0120. You have to keep it in 3 significant figures. 3 sig figs here, 3 sig figs here, so you have to keep it in 3 significant figures, 0.0120 moles. That's the average number of moles. And similarly, you have to calculate the average number of moles of oxygen that combine with the magnesium. For that, you need to take the mass of oxygen. So you're going to be using this number and this number to calculate the average number of moles. So you take 0.161, and then you're going to divide it by the molar mass of oxygen, which is 16. This is in grams, 16.00 grams per moles, and this will give you 0.0101 moles. And similarly for the second trial also, you're going to get the mass of oxygen and you divide by the molar mass of oxygen to find out the number of moles, that is 0.0110 moles. And then to find out the average, you add these two together, 0.0101 and 0.0110, and you divide by 2. That will give you the average number of moles of oxygen. You will get us numbers like this. Okay, 0.0106 moles. That's the number of moles of oxygen. Now we found the molar ratios, number of moles of oxygen and number of moles of magnesium in the previous calculation. Now we're going to find out what is the simplest ratio between the number of moles of magnesium and number of moles of oxygen. In order to do that, let's go ahead and do the first magnesium. So the magnesium, we found average number of moles, and then we're going to divide the average number of moles of magnesium by the smaller of the average number of moles of magnesium or oxygen. So let's see what we're going to do. So the average number of moles of magnesium was 0.0120. Now we're going to divide this by the smallest of the two, which is magnesium 0.0120 moles, and we found oxygen average number of moles 0.0106. Between these two, which one is the smallest? Magnesium or oxygen? Oxygen, right? So you take the number of moles of oxygen, you divide it by the smallest of the two, 0.0106. When you divide these two, you're going to get a number like 1.13. So you keep that number. And then you take the number of moles of oxygen, average number of moles of oxygen. We found that to be 0.0106 moles. Now this one you're going to divide by either magnesium 0.0120 moles or oxygen 0.0106. Again, the smallest of the two. Which one is the smallest? This one. So you divide it by 0.0106. When you divide a number by the same number, that would be 1. So we found two ratios, 1.131. Normally, if we cannot leave decimals or fractions in our empirical formula, we want to make them to whole numbers. So our ratio is magnesium to oxygen 1.13 to 1. Now 1.13 is very close to 1. So we're going to round it up to 1. So that will make magnesium 1, oxygen 1. So the empirical formula or the smallest whole number ratio is going to be 1-to-1 ratio. So as a result, the empirical formula of magnesium oxide is MgO. Okay, so that's how you're gonna do the calculations for this experiment. That's all you need to do. Okay, you don't have to worry about the rest, the pre-lab assignment or anything like that, since we are intro to Chem. Just do the calculations and turn in your lab report. Okay then, bye-bye.